So now let's look at the junction between the smallest normal number and the largest subnormal number. So again, we're talking about positive numbers here. So you can see that the smallest normal number is given by this hex number here, 008 with 5 zeros, and I've written that number up here, so that's in 32-bit binary. So let's go ahead and we'll have a look at this in the conversion tool. So the smallest normal number is going to have a 1 at the exponent here. So we're going to have the value of 1 minus the bias 127 will give us a value of minus 126. So we're going to have 2 to the power of minus 126. So we're going to shift the window all the way down towards 0. So remember, whenever you write the exponent here, 2 to the minus 126, it's not given as a negative number, it's given as a fraction. Whenever you have 2 to the minus a power, it's the same as 1 upon 2 to the power. So it's just like going down towards a very small fractional numbers. So if we have a look at the mantissa here, you see the mantissa is all zeros. So the next number up would be a value of 1 in the mantissa, which would be at the very last bit. So that would be this value up here, and we would be adding on 2 to the power of minus 23. But we're not doing that here. We're going to make it to the smallest normal number. So we'll take that value off. So we're going to have our 2 to the 126. We're going to have our 0 for the mantissa, and of course we've got our 1 plus our 0. So we've got 1 plus a 0 times 2 to the minus 126, and we also have the sign here. So if this was a 1, it would be a minus value. It's a 0, it's a plus value. So we've got the smallest normal number here. So let's go ahead and we'll have a look at this number in a bit more detail. So the smallest normal number is going to be the hex number 08 with 6 zeros, and that is equal to 2 to the minus 126, which is 1.175494350822229 e to the minus 38 approximately. So if we were to write that out mathematically, we're just going to have the value of beta, which is the radix. In this case the radix is 2, and the value of E min. Now the value of our E min now has been defined as minus 126. So we're simply going to have beta to the power of E min. So let's go ahead and we'll look at the next number down, which is going to be the largest subnormal number. So we're now looking at the next number down, which is the largest subnormal number, and that's going to be given by the hex number 007 and 5 Fs, and you'll see I've got that written here. And you can note here that we don't have an F in this position here because there's in fact 23 bits here. So the last 3 bits here that we're going to have, or the last set of bits, is only going to be have 3 positions, which is going to give us 1 plus 2 plus 4, which will be a value of our 7. So let's go ahead and we'll have a look at this number here in the conversion tool. So I left it here with the smallest normal number. Now, in order to go to the subnormal numbers, we ensure that the exponent is all zeros. So we put a 0 in here. Then if any of the mantissa values has got a value in it, then we will be in the subnormal numbers. So the largest subnormal number is going to be all 1s. So we make these all 1s. Now you can see that the exponent, the mantissa again, is heading towards a value of 1, but it's never going to get there. It's only going to get as far down as 2 to the minus 23. So this isn't a value of 1, it's 1 minus 2 to the minus 23. So it means that the final result is going to be the 2 to the minus 126. So it's going to give us the window that's down towards 0. And we're going to be multiplying that by the mantissa. And this is a mantissa here. And in this case, whenever it's a subnormal number, we're adding 0 onto the mantissa, so we've got 0 plus this number. And we're going to multiply it by the sign as well, so in this case the sign is 1. If we make this as positive, if we make this a 1, the sign will go negative. So that means that this number here is the largest possible subnormal number. So let's go ahead and we'll have a look at this number in a bit more detail. So our largest subnormal number, which is this number here, and we're at this position here, is going to be 007 with 5 f's. Now that's going to be equivalent to 2 to the minus 126 times a number that's very close to 1. So the number that's very close to 1 is going to be 1 minus 2 to the minus 23. So that's going to be equal to this decimal number here, 1.17549421069244244 e to the minus 38 approximately. And that's going to be 2 to the minus 126 approximately. It's going to be a little bit less than that because we're going to take away this factor here. So in general, if we were to write this down mathematically, we would have the value of 1, that's the value of 1 here. We'd have a value of our radix. Now our radix is beta, which is a value of 2. So it's going to be 1 minus 2 to the power of. Now it's going to be again minus 23. So in this instance here we're using our single precision. So it's going to be 1 minus the value of p. And we mentioned the value of p before. P is the number of significant figures, or it's the number of places that we have for the mantissa, including the one at the front, or the hidden bit. So that would be a value, in this case here, of 24. So it would be 1 minus 24, which is a value over minus 23, times the beta, which is 2, times the E min, which is the minimum range for our exponent, which is minus 126. So we can write it down mathematically like this. So that's us finished with this junction. What we'll do is we'll move on in the next video and we'll look at the next junction down. So this is the junction between the smallest subnormal number and an underflow to 0 plus. So thank you for listening. I'll get you in the next video. Goodbye.